Hi there once again and welcome to another Expresso mechanic tutorial, and this is the second in a three-part series on building a kinetic sphere exchanger. In part one we focused on building this device over here, which is the slide assembly. We can see that working. In this tutorial we're going to be focused on building this, and there's actually two of these, one on the left, one on the right, and it is of course a pneumatic ram with a spring-loaded button. So we're going to be focused on building these and getting them all working. That's what we're about in this tutorial. So without further ado, let's see if we can make this happen. I'll start by bringing in a tube and we'll start resizing it. So its outer radius needs to be 22, the inner 20. Rotation segments, once again, I'll go 60. One cap segment is fine. The height needs to be 12. And height segments, just 1. I'm going to group this into the trough. And in the coordinates, zero out the Z. And then we can place this along its x-axis at 190. Now, if we just switch to our front view, so F4, we can see, if we get a little bit closer here, we can see the base of the trough is here, but this is slightly below it. So we need to raise this in the y-axis or along the y-axis by 1. And now it will line up. So that's all looking good. And we've got our first element of the pneumatic ram built. Moving on from here, we need to bring in a cylinder. It needs to be 20 in the radius because it needs to fit within the tube. Its height needs to be 75. And height segments 1 and 60 rotation segments. We'll group this into the tube, and in fact what I'll do is remove this tube from here and just place it at the top for now. And then we can zero along the X. Oops, that's the wrong one. We need to do it with the cylinder. 0 along the X, 0 along the Z, and we need to position this correctly. So it's 75, let's see, 37.5, and we should be in the correct position. We'll just check that in the front view. So F4, and we're okay. So two of our elements are now ready. We can remove the cylinder from the tube. And we can think about bringing in a couple more tubes to make the rest of the object. And we're also going to be making use of bools. We need a couple more tubes. So for a start, I will copy this one to give us an extra tube. Its outer radius needs to be 12. Its inner radius 7.5. 60 is great for the rotation segments, and the caps are okay, and the height needs to be 20. Plus Y is fine because it's in the correct place, and we can simply move it up. Just about there is fine. I mean, we can do any adjustments afterwards. It should be fine though, no matter where you put it really. But anyway, that's the first tube made. If we just command drag to create a second one, we know that this will want to be plus X because it's going to sit here somewhere. In fact, what we need to do is group this tube into this cylinder and zero out the y-axis. We can remove it once again, and we can now just pull it back into the main cylinder there and do a little bit of adjustment with regard to its sizes. Now we want this to be 10, this to be 6, and that's it. Everything else can remain the same. So we've got our basic shape of our pneumatic tube set up. The next thing to do is group everything into a null. Call this pneumatic tube. And then we can think about creating a bool. So this here, the main cylinder, this will need to be placed into a bool. So we'll bring one of those in there, holding down the Option key. We can then group tube 2 into group, or rather into tube 1, and then tube 1 can be grouped into a bool. We can now place this bool directly under this cylinder, and we're seeing something happening. It's not right because we need to set these things up. Now we don't want subtract, we want union, and now we should have things set up correctly, and it's all looking good. It just gives you a nice shape so that when you render, it actually looks like a whole object. It's quite a nice way to do it. We haven't got create single object, but we can check that if we want to, but it doesn't really matter. High quality is essential though, because we do want a high quality bool. Hide new edges, absolutely fine. I think the rest can be left alone. I mean, if you wish to do these, you can, but I don't think it really makes an awful lot of difference. But anyway, that has set all of that up and it's all working correctly. So we've now got the pneumatic tube completely built. Moving on from here, we need its opposite number over this side. Well, the easiest way to do that is to bring in a symmetry object. It's in the middle of our scene, but it needs to be moved. Well, I suppose it can be left. Let's just see if it can be left there. If I just place this in there, yeah, it doesn't matter. I was going to say that it needed to be placed in the middle of the trough, but it doesn't actually. If you just leave it where it is, it actually sets things up fine, so don't worry about moving it. But that gives us both of our pneumatic tubes, which is great. So we've got that, so we might as well rename this pneumatic tubes. Okay, fantastic. So we've got that done and we're well on the way. We'll just move this trough up to the top, I think, so that we've got both of our inanimate objects at the top of the object list. Okay, super. So we can think about making the spring-loaded buttons and, of course, the actual rams themselves. We need those. They're the next pieces that we need to model. We'll bring in another cylinder and place it at 190 along the x-axis. Again, I'll group this into the trough and zero out the z-axis. Remove it from there. Now this cylinder, the radius needs to be 15. In fact, no, that's not right. The height needs to be 15. The radius needs to be 22. And we can move it up here because it's got to sit on top of this, obviously. Height segment's just 1 again. 60 rotation segments, make it nice and round as before. And cap segments, will give it 2. In fact, we'll make it 3 because we've got to do some work to dish this out at the top so that it catches the sphere. Let's just switch to our front view, so F4, just to make sure where we're going to place this. And it should, well, in fact, it's pretty well placed. It can be just there really by eye, just so that it sits on top of that tube here. That's absolutely fine. And if we switch back to our 3D view, we can have a look and see what's going on here. Now we'll make this editable and switch to point mode. This point here we can drop just a fair way down. Again, this doesn't have to be an exact science, so we'll say UL, and hopefully we can select this inner row of points. If we just select that inner loop there, if we can just drop those down to around there, UL again, and we'll select this inner loop, spacebar, and then just drop that down somewhere there. So let's just dish that out a little bit. We can dish it out some more if we really want to. We can go a little bit further with that. We can just drop that down a little bit further. Select this center point, drop it down. UL once again, select this inner loop, spacebar, drop that down So it's somewhere there, just to create that dish effect. Okay, that's looking good. So that's ready. Moving on from here, I'm going to switch back to model mode for a second and just bring this up. And we'll take a quick look at what we've got underneath there and whether or not we think that inner loop of polygons, which I'll just switch to polygon mode, UL, to select this loop of polygons. If I say D for extrude, I'm going to bring that down 75 and we'll see if that's fitting okay. And I think it is. It's pretty perfect actually. That's good. That's really good. Yeah, there's a little bit of play in it and that's fine. I don't mind that so much. It's not a huge amount and I think that that will serve our purposes. If you wish to make that tighter, you could always select by UL, select this loop and then scale them. Just select the scale tool. Don't worry about the Y and just bring those out if you wish to do that. So it's entirely up to you. I'll leave mine like this now that I've done the scaling. So that's all set up and ready to go. We can now think about moving the cylinder back into its initial place. So let's just switch to our front view, F4, and we'll move this down until it sits on top of our tube somewhere there. That's looking good, like that. Now the next thing we need to do is actually zero this axis out at the what we want it to be at the bottom here. So that's going to be its start position, its 0 point. So if we grab a hold of our axis center tool and we move this minus 100%, we've got it in the right place. So that's fine, that's ready to go. And now we can group this by holding down the option key into a null. And that's set that up. We'll call this, as we'll say this is the right RAM. I mean it's stage left, but we'll call it the right RAM. So right RAM, and we'll call this right. Okay, great. So that's ready, and we can copy this, and then in its coordinates we can move it. We want to move it along the x-axis just minus 190, and that's in position, and we can then rename this left RAM and left. Great, so those two are ready to go, and I'm going to place these at the bottom of the object list if I can get them down there. Yeah, we don't want them in there, just move that there and drop that above there. Okay, great, so they're in position. We'll just do them that way. That's fantastic. So moving on from here then, we can produce the spring-loaded buttons. I'll bring in a null and rename it T3 and drop this into this cylinder just above T1 for now. Now at the moment this needs to be zeroed out so that we can see where we are, and then we can remove T3 from here, place it up the top. At the moment it's at 105. It needs to be 130 along the x-axis. That's its starting position. And then from there we need to get a copy of this cylinder, drop it into T3 and remove T1, and then we can think about placing this. Now this needs to be zeroed out for now, and then we can switch to our front view, so F4, and we can see that it's centered within T3 at the moment, and it just needs to be set to 5. So our cylinder is now on the leading left edge, or rather I should say T3 is on the leading left edge of our cylinder. Now let's just check what's going on with T1. Now T1 at the moment we can see is just back from the right hand leading edge of this cylinder that's attached to the slide. So in this case what we need to do, rather than 4.8, it needs to be 5, and that matches the two of those up. So when this has been moved over here via the slide, T3 and T1's positions along the x-axis are going to match up. Those two are going to be butted together, and that means that T1 will be able to then pass its position to T3 at that exact moment, from that moment onwards. And that's how this is going to work. So that's fine, that's all looking good. We now need to replicate this for our cylinder here and T2. So if we bring in another null and call this T4, switch back to our 3D view, so F1, T4 can be grouped into the cylinder 1 there. Again, we'll zero out and then set this to minus 130. Or rather, no, we won't do it then. We'll remove this from here first, and then we can set it to minus 130. So that's now in the correct place, and then all we need to do is create a copy of this particular cylinder and drop it into T4. We can zero that out and make it minus 5, and then that's in the correct place. And we can check that if we just switch to our front view, so F4 once again, and hit O for object, and we can see that that's perfectly good. Now we also need to check T2, which is currently minus 4.8. That needs to be minus 5, and that matches everything up. So that's fine. We've got our buttons ready to go. We just need to create the slide pieces and the springs, and that's what we're going to be doing next. Right, so what we'll do is copy a cylinder here, and we'll group that like that. This cylinder, we can change its sizes, so its radius needs to be 6, its height 25, and everything else can stay the same. I'm going to switch to my front view, so F4, and drag this here, and we can just leave it like that. That's fine. Same thing again if we switch back to 3D view for a second. Again, command drag to copy this cylinder, group it into here, set it up the same, 6, 25, right hand view, so F4 once again, O for object, zoom out a little bit so that we can see where we are, and then all we need to do is drop this here, and that will work perfectly well for us. Oops, wrong way. Let's just go that way. I thought I'd done that wrong when I did that. That looks good. That looks as if that's going to work fine. Yep, that will be perfectly good. Okay, so we've got those set up and they're ready to go. The next thing we need to worry about is the springs. That's the final piece that we need to worry about for all of the pneumatic rams. So we'll grab a hold of a helix. It needs to be in the ZY plane. The radius can be 7, and the end, well, the start radius and end radius can also be 7. The end angle, I suggest we add 360 degrees to 720 to make it 1080, and its height can be 20.5. Now at the moment our helix is still in the centre of the world, so we need to group this into our cylinder here, and we can zero out. So we've got it in place, but we're not quite right yet. If we just go into our front view once again, so F4, hit O for object, and we'll see where we are. So we're not in the right place. For a start, we need to rotate this 180 degrees in its heading, so 180. And then we can draw this back into the correct position, which is going to be somewhere around here. So our spring is now getting towards the stage where it's complete, but to finish it off, we need to bring in a circle. We'll drop this just above the helix, and it needs a radius of 1. We can select the both of them, hold down Command and Option, and then drop them into a sweep. And we've got our first spring. Before we go any further, what I'll actually do, I'm going to remove these two from here. drop the sweep into the helix and zero it out, just to make sure that we get that in the correct spot. Okay, so that's 0, that needs to be zeroed on there, zero that out, that's it, that's perfect. Right, so we've got that in the correct place. We can drop those two back in. So they're in there and our spring is ready, and that's there. That's great. So now all we need to do is copy this down to here. So we've got two of them. Switch back to our 3D view. And all we now need to do is place this at minus 161.5495. So minus, and we can rotate it by, well, 180 actually, and that puts it in the correct place, and we should be able to switch to our front view, so F4 object, and we can see that we've got both of our springs in the correct place. That's fine, they're ready to go. Okay, looking good. So let's rename them. We'll call this right spring and left spring, and we can just reorder them and then place them beneath our rams. In fact, we'll just place them above our rams. That's where they need to be. Okay, so that's our build complete for this tutorial, and we can place our display in isopalms just to make it look a bit nicer, and we can see that everything is there and it's all looking good. Before we start looking at Expresso, we need to do a little bit more housekeeping. So the originals here, I'm going to move up to the top, or they will be at the top ultimately because we're going to move these two. So these need to be above the slide, just here. So that's T3 and T4, they're in place. And that's good, so everything is set up now as it needs to be. We've got our originals and inanimates that we've got thus far in the correct places. The initial Expresso is there, and then everything else that follows, that's fine. Now T3, we're going to give an Expresso tag, and then we're going to be getting our spring-loaded buttons working exactly the way they need to. The first thing I'm going to bring in is an iteration, and we'll give it an iteration end of 1 because we're going to be working with pairs of objects here. The next thing to do is bring in 3 linked lists. So I'll create one, command drag twice to copy, and then we can populate these with what we need in them. Now the first, we need T1 and T2, so we'll bring those in there, T1 and T2. In our second, we need T3 and T4, so we'll bring those in there. And then finally, we need both of our helixes. So we'll open our springs and get a hold of those. So helix and helix. What we'll do actually is name that helix.1 so that we can distinguish between them. Makes life a little bit easier. Okay, fantastic. So we can connect all of these like this, connect these up. For the moment, we'll leave these two alone. We don't actually need to worry about them just yet. So our first linked list is there. We can then bring in T1. So we'll bring this in and give it an object port at the input stage. At the output stage, we will give it a global position X port. So that's ready to go. Moving on from here, we need 2 compares. So we'll bring those in. Once again, I'll just command drag to copy so that we get 2. Now, in our compares, we'll wire them up. So we'll connect the global position X to the input ones. In our top compare, we need a value of greater than or equal to 130. and in our bottom compare, less than or equal to minus 130. Now, if you remember, 130 is the starting point for T3. It's located at 130. So the global position, because of course T1 is actually grouped into a cylinder, so it's got to be its global position. Its global position, once it reaches 130, then it can pass its following positions, its subsequent positions, to T3. And of course the same thing applies with T2 and T4. That's what we're doing here. So let's continue with this. Let's just bring our view back to 100%. So those two are set up. We've got greater than or equal to 130, less than or equal to minus 130. What we then need to do is bring in T1 and T2, and we need to place them under our compare nodes, and then we must give them global position X output ports. Global position X. That's fine, so we can leave those there, just position them there so they're ready to go. And then we need two conditions. So we'll follow the same path as we did last time. Grab a condition and then command drag to copy. Place this here. Now the output of our compares that's going to be the switch. So we'll switch those two like that. And then we need to set these conditions up. Now we need in our input 2 for our top condition, we need 130 because we want to leave T3 and T4. They need to be left in their initial positions when they're not being moved by T1 and 2. So we'll leave those at 130, and in our input 2 for our bottom condition, we'll make this minus 130. And we can then wire T1 and T2 up like that. So those are ready to go. Following this, we need another condition, which needs to be here. And this condition needs to be switched by the output of our iteration. So that needs to be there, and then we need to plumb these two in accordingly. So we're going to alternate between checking the two, or between looking at what's going on in the two. Okay, that's what we're going to be doing there. Moving on from here, we'll grab a hold of our second linked list and we'll bring it down here. We'll just move this down a little bit too. So our second linked list is in place and it's ready to go. We'll place it about here, actually, that's fine. The next thing to do then is bring in T3. That's where we're going next. So we're going to bring in T3. Give it an object port at the input stage that will allow us to plumb in our linked list, and we'll also give it a global position X, although it could be a position X, but we'll use global position X, and we can plumb the output of our condition into there. So we're going to be taking either what's coming out of here or what's coming out of here, and we're constantly going to be alternating between the two. So we've got that set up. We can then give this a global position X at the output stage, and we're ready to go from here. The next step is to bring in two range mappers. So we'll bring those in. As per usual, command drag to copy, and we'll plumb the output from our global position X from the T3 node here into the inputs, and then we can think about the numbers. So in our top range mapper, the input lower will be 130, input upper will be 145. That will work for us in there. Now the output lower and the output upper, we know that the height, if we just move this out of the way, we know that the height of a helix, if we select the object tab, We know that it's 20.5 centimeters. So in our range mapper, we can say 20.5. But we need to know what it needs to be when it's at its compressed state. So let's see what we're going to do there. If we get a hold of our drive sprocket and we move that minus 360 degrees in the rotation B, we've now, because we've got part of this working, we can see that the button has actually been pressed in, and that's fine. So what we need to do next is get a hold of this helix, or rather this helix, and we need to reduce its height. So let's do that, see where it needs to be. It looks about 5.5. I'd say 5.5 looks very, very good. So in our top range mapper, we can put our output upper as 5.5. And that's fine. Now in the bottom range mapper, the figures are going to be similar, except that we need minus 130, minus 145, and then 20.5 and 5.5 once again for the output lower and output upper. So that's those set up. Moving on from here, we need yet another condition. So we'll command drag to copy this one, bring it over here. Now once again, this condition will need to be switched by the iteration. So if we can make things a little bit smaller, I think we'll just zoom out a little bit on here. Just make that a bit smaller. We can see the iteration output now. If we grab a hold of that and we plumb this in here, and then we can switch, or rather we can plumb these two in here and then switch between them. Oops, let's just hit H. We can plumb those in like that, and then we're alternating between those. That's great. That's what we want to do. And then finally, we need this link list that we've not used yet with our helixes in. If we place this over here, we can then bring in a helix. We'll just bring in this one, give it an object port, and give it a height port. So we'll come down to our object properties and select height. So we'll swap those over because the object is coming from this link list. That's going to plumb into there, and the output here is going to plumb into the height. Right, it's changed and it isn't correct. Let's see why that is. Let's have a look. Let's have a look. I'm looking at the wrong one because I should be looking at this one. So I've got 130 to 145, 20.5 to 5.5. Let's see what happens when I move this. If anything happens at all, nothing is happening. What happens if I do this? Nothing is happening. So I've got an error there that I need to check out. I think actually that I know what the problem might be. If we come into our link list here, yeah, let's just swap these round. Ah, and now it's right. Yeah, so you need to put the helix 1 at the top. That's the only difference. Now let's just close this down. Just make sure that everything is working in both directions. If we switch back to our 3D view, let's see what happens now. That's not quite right there either, is it? So we've got another issue. Let's have a look, see what we've got. Where are we? We need to take a look at T4. Where is T4? T4 has moved. We don't want that. Okay, let's zero that out. So T4, if we drop T4 back in here and we zero this out, zero it out there, that's better, it's in place. That's okay, and we can take T4 out of there and drop it up there. Let's see what happens now when we play around with our drive sprocket. Okay, so let's select our, yeah, that's working fine. So we can see that the right hand button is working correctly. Is the left? Yes, it is. There you go, they're both working. That's fixed it, that's all right. That's working perfectly. Superb. Okay, brilliant. So that's all working as we need it to, and it's looking really nice. So let's have a quick look at our expression so that we can see everything. Just move down and hit H. So it's quite an involved one, I suppose. There's a fair bit in it, but when you think about it, all it's really doing is looking at T1 and T2 here. We're alternating between them and checking their positions, and once they reach either 130 or minus 130, then we simply switch and give their positions to T3 and T4, because of course they're being alternated, or rather sequenced I suppose, one after the other, and then repeating the process again via this linked list here. So that's all going on in here, and then the outputs from T3 and T4 are being passed to the range mappers as they need to be, and then those values are being passed to our helixes, which again are being sequenced here. So that's all we're really doing, and it works really nicely. So that's our first expression complete for this tutorial, and now we need to concern ourselves with making the rams behave as they should. Our final Expresso expression I'm going to place on the left ram, so we'll give that the Expresso tag. It's a little bit big at the moment, so we'll just shrink this down so that we can see what we're doing. Okay, now the first thing I'm interested in is actually the compressed height, the compressed height of any of the springs. So if we select a helix and look at its object, what we'll do is just padlock that so that when we move our drive sprocket, we don't lose what we're seeing there. So if we move this until we get to our compressed state, which is exactly 360 degrees of rotation, so if we set that to 360, so we do get to 5.5. What I will say though is I'm not going to use dead on 5.5. We'll go slightly before then. So let's bring in both helixes. That's the first thing we need to do anyway. We'll bring those both in. So I'll command select and then drag them in, and we can give them at the output stage height ports. So we've got those two set up. We need a couple of compares. Once again, I will, oops, don't want to do that. Just command drag to copy. And we can connect the height outputs to the input ones of the compares. Now, the input 2 on both these compares can be the same. Let's just take the padlock off. Let's just reselect those again. We can say less than or equal to. Now we said 5.5 was the compressed state, but let's go 5.6 just to allow ourselves a little bit of leeway. And that's fine, that's as much as we need to do there. We then need to bring in a flip-flop. And what we're going to do is connect our compare here to the on input and our compare down at the bottom to the off input. Okay, so they're ready to go. So when this outputs a 1, this will be switched and we'll get a 1 at the output stage or a 0 at the output stage if we switch this one. So the flip-flop's going to alternate between a 1 and a 0. Okay, that's how this is going to work. Let's just try that out. We'll get a result node and we'll see what's coming out of there. Now at the moment we're getting a 1, which is, in actual fact, it's helix 1 that's doing that. I think you'll find, because helix 1's the one that's good, or rather, is it helix 1? No, it is helix. It is helix. What I thought it was. It is helix. So the helix over here, that's producing a 1. So this is triggering this, and we're getting a 1. If we grab a hold of our drive sprocket and go over the opposite direction, and we trigger this one, in fact what we'll do, make it easier on ourselves, if we put 360 in there, or rather minus 360 I should say, minus 360, we get a 0. We get a 0 with the output. So that's how this is working. So that's fine, we know that we're okay there. The next thing to do is bring in a time node. We'll just leave that here. And then we need 2 monoflops. So we'll bring in one of those and command drag to copy once again. Now we can connect the time port from the time node to the time input of both flip-flops. The durations, I'm going to say 15 frames, so half a second. Now the flip-flop, the output of that can be the trigger for both of them. Now, because we're getting a 1 or a 0, this will have to be a one-shot monoflop, and this, because it's going to be receiving a 0 to trigger it, will be a normal monoflop. So this is a situation where you need to use both modes. So they're set up. The next thing we need are 2 range mappers. So we'll bring those in. In fact, what we need to do is add state ports to the monoflops before we do that. We'll bring in 2 range mappers. Command drag to copy, of course. Connect the states to the inputs of the range mappers. And then we can think about the numbers. So we know that in our top range mapper, well, in fact, they're both the same, to be fair. We can just select both of them. It is going to be 0 to 1 for the input and output, or rather the input lower and input upper. The output lower will be 0, the output upper 75. And then finally, we just need to bring in our left and right rams. So we'll bring both of those in, command drag those in, place them accordingly. Now let's see, I think the right one needs to be at the top. If not, it doesn't matter, we can easily swap these over, but I'm pretty sure the right needs to be at the top, but we'll see if I'm correct. So we'll give this a position Y port and this the same. Okay, and that's fine, that's ready to go. Just set those up accordingly. As I say, if it's wrong, we've only got to swap them over. That's no problem at all. So let's just shut this down. And then what I'm going to do in my drive sprocket here, set this back to 0. I've got 90 frames. If I go, let me think, well, I'll put 1,000 frames in there for now. It doesn't matter. I won't be using that many. What I'll do is record this at 0, at frame 0. And then we can move this to 180 frames. And we will rotate through, I think, well, we want one rotation of this large wheel here. That's 4 rotations of our small wheel. So if we say 1440, that gives us those rotations, and then we can record that there. Now let's see what this does. We'll also go into our F-curve, timeline F-curve, and we'll make this a linear curve. Right, let's see what happens. Right, they are back to front. So we need to go into our Expresso expression here. Where are we? Just down the bottom here, that one. Go into here, and all we've got to do is swap these over. Just put that one in there, that one in there, and then place them accordingly. Now, they're not quite working as they should yet because we've still got some work to do within the range mappers. What we need to do is work with the curve here, the spline. If we put a point down here, another one up here, we'll twirl this down so that we can quickly put these in the correct place. If we put this one at 0.2 and place another point at 0.6, and our final point we need to place down the bottom here, and then we can work with our tangents. So minus 0.25, once again minus 0.25, same again, and this one should already be 0.25, and it is. That's correct. So that's the kind of curve I want in there. Right, let's see what we get now. There we go. And that one should fire. Haha, I haven't given enough frames. The reason that doesn't fire, there is a reason. If you've already got a 1 or a 0 in the flip-flop and you go in the direction that will produce a 0, then it won't fire. Similarly, if the flip-flop is already set to 1 and you go in the direction of an object that requires a 1, then you're going to get the same result. It won't fire. So you've got to bear that in mind with a flip-flop. But that's the only reason that doesn't work. And there's not really any way you can do anything about it. So that's fine. That's all looking okay. The only thing we can do is perhaps give ourselves a few more frames and go a little bit further with this. So, well, we're at that. We did it 180. If we go to 360 and set this up accordingly, go into our drive sprocket and we say 2880. That's fine. And let's see what we do now. So we go that way. This time we do fire because we'd already gone in the opposite direction, and we're firing. You can see that it's working. Yeah, that's doing exactly what I want it to do. Yeah, perfectly good. So we can see that that's all working really nicely. So we'll take another quick look at our expression. So we're getting the heights of our helixes. And once they're compressed, because that's what we're comparing to, less than or equal to 5.6. So once they've been compressed, we're then triggering the flip-flop. So we're either going to get a 1 or a 0 at the output stage. When we get a 1, we trigger this monoflop and we move our left ram and it goes through its motions. And similarly, if we get a 0, we trigger this monoflop and we move the right ram. That's all we're doing there. So it's quite a simple expression, but the flip-flop is quite powerful actually. It's doing quite a lot. This setup here is doing quite a lot, and it allows us to do some quite nice moves. So that's a nice little expression that you could probably use elsewhere. But anyway, that just about brings this tutorial to a close, because I've shown you everything I wanted to do in part 2 of this series. So, as always, I really hope you've enjoyed doing this tutorial. I've certainly enjoyed bringing it to you. And I look forward to seeing you in part 3, in which we're going to be dealing with the dynamics. We're going to be building the wire forms, and we'll get the spheres in, and we'll get everything moving and get the whole thing working as we want it to. So that's for part 3. If you have enjoyed this video, as always, please give it a like, and if you haven't already, please subscribe to the channel, leave a comment and ring the bell. And wherever you happen to be on social media, then please do share this video, because all of this good stuff really does help keep the channel moving in the right direction. But that just about brings the curtain down on this one, so I'll see you very soon in part 3.